Hello everyone, thank you very much for coming. In recent years we've seen lots of major improvements to JavaScript language. At the same time, platform vendors have improved runtime performance, so that applications run way faster. All this led to an explosion of JavaScript ecosystem. Lots and lots of new tools, libraries and frameworks have been introduced in order to improve our productivity as developers. Most of those tools rely on standard imperative approach, where a developer is responsible for many low-level details such as keeping consistency between variables, etc. But more and more of those tools reach out to declarative style of programming, making those tools more powerful but also more complex at the same time. In this talk, we'll take a look, we'll dive deep into some design decisions behind the tools that reach out to declarative style of programming, thanks to inversion of control techniques. My name is Tomasz Ducin. I'm an independent software consultant. I work as a software architect and developer for big-scale, usually enterprise applications. I help developer teams to better understand the software they create, help them create it faster, and help them scale it. I also do trainings on front-end technologies, including JavaScript, TypeScript, React, Angular, functional programming, architecture, and so on and so forth. So if you're in need of consultancy or training, feel free to reach out to me. So let's start with talking about inversion of control by breaking the term into smaller pieces. So first, inversion. We have to define, before we invert something, we have to define what is the default direction, what is the application flow, how does the code behave, how does it basically work internally. So I believe that speaking about architecture and design, which is pretty much abstract, is way easier if we consider real-life metaphors, not software examples, but real-life metaphors. Just pick something from the surrounding world and analyze it and take it as an example. So, about inversion. Let's imagine that we are in our flat, awaiting for a post delivery. We're about to receive a letter. And now we need to define what is the default. So the default situation is I am awaiting a postman to come to my flat, knock at my door, and basically to give me the letter. However, if it happens that I'm absent, let's say an exceptional situation, or that the postman is just too lazy to walk up the stairs and knock at my door, which happens unfortunately too often, in our country, I guess. The postman would just drop the post notification into my mailbox, inverting the control, so that now I am responsible for picking up this notification, walking to the post office, waiting in the queue, and the inversion in this case is basically changing something very convenient for me, basically awaiting receiving a letter, to something that is a lot less convenient. But basically, we can see the inversion. Usually, if we invert the control, we would like to invert it in a way so that it is more convenient for us. What is important here is that when we invert something, we're actually switching one responsibility to another responsibility. In the beginning, by default, it was the postman's responsibility to deliver the letter, and now it is my responsibility to walk into the post office. Another example is if we make an order in an online shop, and we have already paid it, we have decided what is the shipment method, and so on and so forth, and we are awaiting for this order to be delivered to us, and for some reason 2 days has passed and there is no delivery, 5 days has passed, or even 2 weeks, and we are wondering what is wrong. So by default, we would have to look up what is the telephone number to customer care, or some kind of, just a phone line to the shop to ask what is the problem with the delivery, like where did it get stuck. But some online shops again, invert the control in a way that instead of us calling them, we would make them call us, knowing all the details. So, using just a standard form, this is just an example, never mind what the, which shop is it, we would choose which order are we speaking about. We would choose whether the problem is about the payment or the delivery, what is the subcategory of the issue, etc., etc. And finally, when we choose either email or telephone, we submit what is our telephone number, and the customer care would call us once a consultant is basically free and available, so that we don't have to basically dial the number and wait for 2 minutes or 20 minutes listening to irritating music, but we would be awaiting a call from a consultant that would know what are the order details, and potentially, as we have defined what is the category and subcategory of the problem, what potentially might go wrong, so that the consultant knows quite a lot before the conversation has even started. So this is an example of making it more convenient to us. Finally, let's take a look at this tweet. Here a woman is writing that her husband has lost a job and he is looking for a JavaScript position somewhere. Now, a default way of recruitment is that we would have to apply, submit our CV and a motivational letter to one company and another company and another, and so on and so forth. But here we can invert the control by basically broadcasting the information so that the target audience is a lot wider, again making it more convenient to us, because instead of submitting directly to certain addresses, and including modifying the CV, including modifying the motivational letters, and so on and so forth. This way we can broadcast more generic information, do it once, and as you can see, there are like 2,000 likes or forwards. Basically, this message has got a pretty wide audience. This is just inverted recruitment, right? So, I hope now we have a picture of what inversion could be. So now let's talk about what could be a control. I believe a good example is basically how to drive a car. So when we drive a car, we need to decide, well, should we speed up, should we slow down, should we turn left, should we turn right, or we're responsible for lots of low-level decisions. If we can see that in front of us there is a yellow traffic light, should we speed up, making it risky that we cross the allowed speed limit, or should we slow down because we don't want to risk crossing a red light, right? So we are responsible not only for keeping in mind where do we want to get, what is our destination, but also making all these low-level decisions. And this introduces pretty much overhead. However, we could invert the control by introducing a very specialized object that would basically know how to deal with all this low-level stuff. In this example, this could be just a taxi driver. And this taxi driver would have a very simple API, basically hiding all the details inside. So this public API in this case could be just take me to taxi.takeMeTo, and here goes the destination point. Now, if we invert the control, you could say that this could be a facade pattern or adapter pattern or factory or whatever, or command. But what is important here is instead of only hiding implementation details, inverting the control means also that we are losing the control. Because now, if I say, please take me to the hotel, I'm not deciding what the route is. I'm not deciding how fast should we go. I'm not deciding where should we turn left or where should we turn right. It's beyond my control from this point. So the pro is that we get our stuff in a more convenient way for us, but we also lose the control over details, which is very important. Usually we do it when we don't care about all those low-level implementation details. Another example is airplane pilots. they have, like, in this cockpit, they have like few orders of magnitude more funny buttons and screens and lots of different things to touch comparing to a car driver. But nevertheless, a car driver is responsible for basically operating the car. An airplane pilot is responsible for operating the plane. However, a car driver is responsible for, a car driver is in some way independent, that if he or she wants to drive straight or turn right, a driver just needs to see whether the path is just free. If it's free and if there is a green light, we can just go there. However, if an airplane pilot wants to land or wants to take off, just basically fly away from an airport runway, they cannot do it, because if multiple planes would like to land at the same time, there would be obviously a crash, right? So if an airplane pilot wanted to land and there would be basically no proxy between different planes, then an airplane pilot would have to call basically all potential pilots that are flying all around in this space, and also calling the ground whether a runway is free to land. Right? This would be super inconvenient for them. So in this, for this reason, a control tower is introduced so that it becomes a proxy between many airplanes that are both flying in the air and that are sitting on the ground. So the airplane pilot is basically giving away the control meaning the pilot stops to decide whether he or she can land or not, whether he or she can take off or not, but it is the control tower that decides. So in case of a taxi driver, or maybe in case of a passenger that calls a cab, the API is asynchronous, meaning when I say please take me to the hotel, I can do other stuff in the meantime, right? In terms of an airplane pilot, when the pilot says I want to land on this airport because I'm supposed to, and the control tower says you have to wait for 10 minutes, this is a blocking API. Right? So car driver is async, non-blocking. This is sync, and this is blocking, because if it says that you will be able to land in 10 minutes, it means that the plane will have to fly over the airport until the runway basically becomes free and available. So we could say that this is in some way a mediator pattern that mediates between certain airplanes. We could also say that this is some kind of a pub/sub, that all the airplanes are both publishers and subscribers, and they do not know about each other, and this is the key here. But the important thing is we want to get rid of some of the responsibility away from a car passenger, from a taxi passenger, or from an airplane pilot, so that it doesn't mean that it's easier. Because this system, it's not easy. I'm not sure if you know how responsible is the work of somebody who works in a control tower. It's very, very hard job. You have to be really focused pretty much every minute when you do anything. It's not as easy as our job. But it makes it a lot more convenient for the pilot to do its job. So to sum up, what we often do when inverting the control is we switch away from imperative to declarative. Now, in imperative programming, we need to take care about low-level details such as should I turn left or should I turn right? And now I remove all this low-level details in favor of declaring what I actually want. For instance, I want to get to a hotel and I don't care how I do it. I want to land. And I don't care how do I calculate whether it's possible now or not. So basically, getting rid of how in favor of what I want to get. Now, Inversion of control is very often misunderstood and mixed with dependency injection. Still, very many people confuse the two terms thinking it's the same. It's not. Dependency injection is only one of the reifications of inversion of control. Reifications meaning a potential application, way to apply a pattern, not yet an implementation, just way to apply an idea. So in JavaScript, it was AngularJS and then Angular who popularized dependency injection among JavaScript developers. So how many of you have used Angular or AngularJS? Raise your hands. All right, a couple of people. So in short, dependency injection basically allows me to use my dependencies. This is a component, visual piece of the interface. I am just declaring that there is my service, an instance of my service class. Whenever I want to use this dependency, I just need to define that there is an instance of this class, and there needs to be a corresponding instance, or there needs to be a corresponding class that would be basically injectable. All the logic will be defined within the class. It has to be wrapped with the injectable decorator. Now, as long as a component is wrapped with the component decorator, things would get automatically injected. I believe this is pretty straightforward as long as you've used DI anywhere. Now, if we didn't have dependency injection, we would be responsible for first creating an instance. The second thing, if the instance itself has dependencies, we would have to resolve those dependencies. This is something very prone to break if the dependencies change. There might be lots of breaking changes, so it's a very fragile piece. Something that if we had to do it manually, we would have to maintain it over and over again. Now, if we inject the instance, if we create the instance, the question is, if this component is visible from the very beginning of the application, then in order for this component to work, the instance of the dependency is required, so that this dependency would have to be created upfront. At the very beginning of the application. But if this component was rendered dynamically, for instance, 1 minute after the user has started using the application, then we would not have to create it eagerly. We could create it lazily, right? So that only when there is at least one item that requires the dependency, create the dependency as late as possible. So basically lazy instantiation. But the thing is, if this dependency would be shared across multiple consumers, then keeping this point in time, the first point in time where any of those require this piece would also be pretty annoying. Finally, if we want this piece to be reused by multiple components, again, maintaining it manually would be inconvenient and very prone to break. So the problems that dependency injection solve is creating the dependency, so basically using the new keyword and the constructor, resolving the dependencies if there are further dependencies of that dependency, lazy instantiation, and sharing the item between multiple consumers. Now, if we introduce dependency injection, all of those 4 problems disappear, but the cost is we need to learn how does this sophisticated engine works. Obviously, the authors have made sure that it's as easy to use as possible, and now our only responsibility is to declare what is the type, what is the class, and make sure that the class is wrapped with the injectable and the component is wrapped with the component decorator. But still, there are lots of tweaks and lots of not necessarily obvious things in Angular dependency injection and module system. So this is the cost that we need to learn the tool. So now I would like to show you an alternative. This library is called TypeDI, and I would like us to concentrate on these 3 lines of code. Dependency injection is not only confused with inversion of control, like thinking that this is the same, but it's also confused with the pattern that we see here. This is not dependency injection, because basically we can see that this coffee maker, this is, by the way, this is a snippet of code that is available in the README on this side here. We can see that those dependencies are not injected into the class, but they are pulled from what is called the container, right? So this is a completely different approach. If we take a look here, we can see that this component is not doing anything to get those dependencies. This component is basically passively being injected the things from outside. The component is not doing anything. At the point of calling the constructor, this is called constructor injection, the dependencies are basically passed into it. But here we can see that the constructor of this class has to actively pull for the dependencies. This pattern is called service locator, and it's something completely different than dependency injection. Both of these patterns are responsible for managing dependencies and for separating consumer from its dependency, but they do it in a completely different approach. And service locator is actually no way of inversion of control, because if I pull the dependency from somewhere, or if I would just construct it locally, then I'm still doing something on my own. So I do have it under control, right? So there is quite a lot of confusion around dependency injection. Anyway, so let's jump to functional programming for a minute. How many of you used Redux or NGRX? At least a little bit. All right, more people. Cool. As most of us know, Redux is a library for managing the state for our front-end applications, meaning we are trying not to have certain pieces of state spread and distributed all across the application, because it potentially introduces problems like desynchronization between some atoms of the state. We would like to have a single source of truth. Also, we would like the components to be immediately notified when a certain piece of state changes. Now, let's forget, like Redux is very often used with React. Let's forget about React, let's forget about Angular, let's forget about all the frameworks. Let's just be framework agnostic, just as Redux is. And now let's think that there is some global state in our application. Now, this could be, let's call it store, not a Redux store. Let's say that this could be a very big object, or it could be just a bag of different variables holding the application state. Now, what would be the responsibility of component to consume this state if it was not Redux? Basically, if I update the state, and this is a variable, a big variable like an object, or it could be a dictionary or a set of dictionaries, never mind. If I update a variable, nobody gets notified about the update. And this is the problem, because a component would basically have to ask the global state whether something has changed. So, was there a change? No, there was not. And maybe in an interval. So how about now? Did it change? No. So I'm not doing anything. So how about now? A change? No. And then again. Did it change? Oh yes, so I now know that I need to re-render myself, and I would have to update the UI. So what Redux introduces is an engine to notify about the changes, which again removes the responsibility of the component to pull for the state, to ask what the state is, and it makes the store basically notify all the consumers about what the change was. So it solves actually two problems. One problem is that a component, if a component was responsible for pulling the changes, for asking when a change happened, then if a component does it very often, like now, like do you change? No. Is there a change? No. Is there a change? No. Then we're making a lot of, maybe not necessarily requests if it's all local, but we are basically wasting pretty much resources in our application. The more components we have, the more resources we waste. On the other hand, if we would do this pooling not very often, then we would get, oh, there is something wrong here. Then we would get a behavior that, oh, that screen is working. We've got technical issues. Do we know what is the reason? Okay, we can move here. So going back, migration. So going back, one responsibility is that the components have to pull for the state very often, but if it happens that the changes are not updated, okay, so now we have a problem again. All right. Okay, so now I need to have a technical difficulties. All right. So two problems introduced here. If the components need to pull the store too often, there would be a waste of resources. But on the other hand, if the component would ask too rarely, then there would be a risk that the UI would get out of sync, right? That there would be some stale data displayed. So a very simple idea is that basically a store, instead of being, let's say, passive data storage, it will start to notify. And here I introduced two arrows. One is R, the green one for read. The second one is W for write. But basically in both Redux, NGRX, and other implementations of Redux, R is basically the subscription, and W write is the dispatch. So that when a component is a user clicks a component, there is some user interaction with the component, or if there is some data fetch, then a component is dispatching an action, producing a new state object, but immediately it is also notifying everybody that is interested in the change. So component would be responsible for managing the changes to anything that it is interested in, but by introducing Redux, component gets rid of this responsibility to track the changes. It only subscribes, and it will be the changes would be pushed to the component. It will be basically injected it with whatever it's interested in. So we're trading pull for push. Pull versus push is one of the most fundamental distinctions in programming. In some situations, pull is more convenient for us. Push is very useful whenever there are real-time changes or there are lots of changes happening. Basically, with pull, we are responsible for tracking all the changes, when they happen, and who might be interested in them. However, switching to push, we lose the control over when do we ask for it, because an engine might basically inject those changes all the time to us. But on the other hand, we don't need to care when does it happen. So Redux API illustrates the pull versus push principle in a very nice way. Redux has only four public methods available. We're not going to speak about replace reducers because this is just a development tool. So there is a way to dispatch an action, meaning something has happened so that the state needs to update, and this is a form of encapsulation. Now, there is a get state, meaning I would like, if a developer, if a designer would like to pull then a store allows us to get the state, or if we want to push the data, we can always subscribe. One of the most brilliant things I consider that was introduced in Redux is that it's a very small amount of code that is very extensible and allow us to make, to integrate Redux with lots and lots of different tools. If we are pull-based, go on. If we want to be push-based, then go on. Now, you might be familiar with the tell, don't ask object-oriented principle, which basically means instead of treating objects as passive storage for data, like anemic entities, anemic objects, that we would basically get the data out from them and manage all our logic within a service, we would like to provide lots of modification, lots of mutation methods into the object so that we don't have to pull the data out, but the object would basically transform itself without the abstraction leaking outside of it. But still, if we take a look at Redux from the tell, don't ask principle, and we take a look at this table at the bottom, we can see that there are read and write operations, and there is also pull versus push. And in this way, pull-based read operation is get state in Redux. A pull-based version of write is dispatch. A push-based read is subscribe. And how about push-based write operation? What operation is this? How would you think? Any idea? If something is pull-based, then it means I control the situation. I have to actively do something. I have to actively ask for what the state is, or I have to actively dispatch that there was an action happening. Now, if something is push-based, it means that I lose the control, and now I'm open for notifications to arrive to me. So if there was a notification about what the state is, then, of course, I can get a subscription, but I cannot passively dispatch any action. Right? There is basically no way to do it. Because if I change something, then I have to do it actively, right? So as you can see, Redux being a very small library, basically allow us to do all the possible three. Now, Redux is an implementation of an observer pattern that is often described as Hollywood principle. The principle says, don't call us, we will call you. If there is a movie actor that would like to be engaged in a film somewhere in a Hollywood and would like to earn a lot of money, then instead of the actor calling the company, would you hire me, would you hire me, would you hire me, again, the control is inverted so that if the company is interested in acquiring the actor, we will call you. Just don't pull us, we will push the notification, we will inform you. Now, we could say that Redux is an observer pattern, of course it is, but the thing is, the critical thing about Redux is components do not know about each other. So, if there is a piece of state, and very often there is a piece of state that multiple components are interested in, then creating a direct dependency or direct let's say awareness that another component exists would make the code strongly coupled to each other, and this would decrease the maintenance of the application. So we need to have a push-based notification with the components being unaware of themselves on each other, and this is basically a pub/sub. So a pub/sub is an observer with a, we could say, proxy in between them. It's just like the airplane control tower. So let's move to React library. React is one of the most popular and widely used UIs. By the way, recently in Google search, React has generated more queries than jQuery itself. So we could think that this is some kind of a breakthrough, that jQuery stopped to be the, let's say, the king and queen of the front end. Now it's supposed to be React. So where does the React names come from? React introduces reactive view updates, meaning whenever there is a state, a private state of a component, the view will update in reaction to this state change. So from the implementation point of view, it could be either my state being changed by me, because this is my private state, or I could receive some properties from a parent, so that if something more high-level changes and it will be propagated to me, I would also change. So this could be either my local state or a state of my parent, which I can see as property called props, but whether it's one or the other, the view will update in a reaction to the state change. So in React, as you can see, we don't define, this is an example of a simple functional component. In React, there is no API to say, get me this piece of the UI and basically remove this piece of DOM, or let's say change an attribute like we did in jQuery or like we do in Vanilla.js. There is no API to create a node, remove a node, change an attribute or a sibling. We don't define what to do. We only define what the view is. So what React introduces is so-called virtual DOM. React creates a virtual representation of the whole UI being a tree, just as DOM is a tree, then virtual DOM is also a tree. Virtual DOM holds the structure of what the interface is for now, and when there is any change in our application, a new state is being generated, and along there is a new virtual DOM, new tree being created. Now we have two trees. We are traversing over the trees, finding out what are the atomic differences. We create a queue, a collection, a list of what changes need to be applied in the real DOM. So this whole approach is introduced because manipulations on DOM are very expensive. If we change only one attribute in DOM, this could have a consequence of potentially updating the whole thing, because let's say if a big div has a layer that would pop up just as being the most on the top, then we would have to recalculate all the layout, right? All the coordinates, all the pieces of each node. So what React is trying to do is try to do as many calculations without touching the real DOM. So if we can do calculations, let's say on a draft, and virtual DOM is the draft, then we will do it. And only if we have everything calculated, we know exactly what to do and when, then we can walk into the DOM, apply the changes in a very short period of time, triggering only one repaint, which is expensive. This is why React is so blazingly fast. And as a consequence, the heart of React is maintaining this virtual structure. This virtual structure, in order to make it convenient for us developers, needs to be a declaration. It's not an instruction, it's a declaration. So we define what the view basically is. Thanks to it, we never make a decision when to change something. We never make a decision which pieces of DOM to update. React will do it always for us. The cost of it is, of course, there is a lot of abstraction that we don't have to interact directly with, but it is there. Now, in React and in many other frameworks, in many other front-end libraries, there is a concept called component architecture, which basically boils down to a separation of concerns into presentational components which deal with logic. They're often parent components, and presentational components which deal with how things look like, and these are the children components often, and container components which deal with the logic. So how a user data should be kept, how to fetch data, how to store the session, and so on and so forth. So there is a lot of parent-child relationship in React. Such subtree forms a whole organism. And in this way, React inverts the control in two ways. First, I don't care which part, as a developer, I don't care which part of the UI to update, because React tracks the changes in the virtual DOM. Also, I don't care about when to do it. For instance, our computers and JavaScript itself is fast enough to do atomic operations in less than 1 millisecond. Like a few years ago, it has gained such speed. But on the other hand, our human eye is not capable of seeing 1,000 changes throughout a second. So it basically makes no sense to do more than, I guess, 24 or 26 different frames per second. So React also includes this limitation of human eye, so that if the changes would happen too often, then there is no need to do all this rendering because we would not even see it. So this is the inversion of control in React. Basically says that we don't care about when to change a piece of a view and which part of the view should be changed. React will track it down for us. Now, speaking about React internally, this is an example of a of a component that is based on a render prop pattern. Now, let's take a look at the first component. It is called some service, and it performs some logic. Now, let's say that this could be fetching some data, keeping it locally, whatever. Now, this component does not say how it should look. Normally, in React, we would define what is the view inside the render method. Now we don't, in this case, we don't do it. The whole idea of a render prop is that this, we have a page component that is a consumer of the render prop. Now, it is the consumer who will pass a render function, so-called render prop. This is why the pattern is called render prop. And only the consumer will tell how does this look. So React is running away from imperative approach into a declarative approach. And in this case, we're defining how the view, what the view is, but not what the view does. And within React, which is already an implementation of an inversion of control, it introduces a pattern where we are falling back to imperative approach again. So in render props, we only define what the this.state could be, so that only our consumer would change how does this thing look like. So all in all, this is one of the most confusing parts of React. I call it that a render prop is some way inversion of control within again an inversion of control. So this is an example of the cost of React. We have to use a lot of our energy to basically understand those concepts. Now, I would like to move to reactive programming and reactive extensions. How many of you have been using RxJS, RxNet, RxJava for at least a little while? Okay, 2 or 3 people. Okay, so I hope that you will get something out of it. In Rx, we the let's say first-class citizen is called a reactive stream, meaning that instead of having a variable, we will define a stream that will notify whenever it changes. Again, let's go back to a situation where we have a variable, we put a value into the variable, and nobody gets notified when it happened or what the new value is. So we would like to create a new type of variable that will basically notify everybody who is interested in it. I believe that the best way to explain reactivity is with what is not reactive. So let's consider a small example where we have 3 variables. The first one, rate. This is an example of exchanging a currency. We would like to go abroad and basically to buy the foreign currency. The first variable, rate, defines what is the currency rate at this point in time. Amount defines how many of local currency do we have, and finally exchange defines how many of the foreign currency will we have after the exchange. Now, this is imperative, this is low level, and this is how processor works, and we don't get pretty much any benefits in a way that if we change one of the dependencies of exchange, if we change one of the pieces, then there is no automatic update, right? There is a desync, and we would have to take care about this manually. Now, if we have an example where we have only 3 variables, it's very easy to spot that this code is broken and that we have to, again, execute this line, exchange equals amount divided by rate. But the problem is, in real applications, we would rather have 300 variables or 3,000 variables, more likely than just 3 variables. And with this order of magnitude, it would be a lot easier, a lot more probable that we just miss something. Right? And each update that is missing is basically a more or less severe of a bug. Now, if we introduce such desync, then desync is bad because our application starts to misbehave, right? So we don't get the expected behavior. The problem is, an exchange is not a variable logically. If you would define what the exchange is, but not from the syntax point of view, but logically, what is exchange? Sorry? Yes, absolutely. This is a function. Whether we call it function time or something else, yes, but this is a function because it does accept 2 parameters that do change, right? And exchange should always reflect what is the relation between them, right? So formally, we say that there is an invariant in this code that says that exchange should always reflect amount divided by rate. The problem with current programming languages is that there is no native support for invariants unless we have a native reactive approach in a language. And one of the things that I'm looking forward in the next decade is that tools like Rx will not be a library that will be basically built on top of JavaScript or Java or any other language, but will be basically baked in. And we will see it in a while. So what we expect is that we define that there is a stream of rates, there is a stream of amounts, and finally, exchange is not a single instruction that we do once and then we would have to repeat it over and over again on ourselves, but we declare it as a relation between the most recent amount and most recent rate. Of course, this piece of code is slightly simplified. Like this is not how you write it, but this is a, let's say, simplification that shows that whenever rate changes, automatically exchange would also change. So now let's look how this would look like in a real application. Let's say that the rate is an observable, a stream of events. Basically, we subscribe to a WebSocket or a server sent events. Anyway, some server would basically push the current rate into our application. The amount is basically how much of the local currency we have, and let's say that we control it over an input. Finally, the exchange is a combined lattice operator. Now, one of the costs of Rx is that we have over 100 different operators, which is a quite significant overhead for a developer to get track of what those operators are. Combined lattice is one of the most important and frequently used ones. It basically says that give me the most recent value of stream A and most recent value of stream B, and so on and so forth. And once you have them, we inject a function, amount and rate, and then basically re-evaluate the function whenever any of the pieces change. So that whenever rate changes to 3.97, whatever, then exchange would automatically update. Now, I like to think of Rx in a way that, oh damn, technical issues all the time. I like to think about Rx in a way that it redefines what a variable is. So instead of having passive variables that are just a container for data, it becomes an active thing that will basically notify and push updates into a consumer. Now, this Rx implementation, this specific implementation, comes along with quite a lot of overhead for a developer to track it. Like, it solves a lot of problems. If you ever have problems with consistency within your application, tracking the state changes, synchronizing, Rx to use in a good way, would potentially solve most of the problems, if not all. But the problem is, it's not the easiest tool to use. Once you get through the introduction, which is potentially really difficult, it's really great. but the overhead is really significant. So I would like to end this presentation with considering what's next, what could be the next approaches for front-end and for inversion of control. Now, I would like to start this part with a tweet that I think is a very smart one. It says, steps in mastery of a programming skill. The first step is, can I do this? Let's say that I would like to learn a new language or a new approach, and I do the most crappy solution, but it works. So now point 1 is achieved. Now, can I do this more easily? Maybe I could replace 15 lines of code with 5 lines of code that do exactly the same thing, because I get rid of unused code, of dead code elimination or something. Now, step 2 is achieved. Now let's get to step 3. Can I do this more elegantly? I replace imperative approach with a functional approach, and I think that I am more up to date and I'm so cool. But the last step that is the most important is maybe I don't have to do it at all, because I can just get rid of it. Now, a very brilliant implementation of this tweet, like I try to like the first, the second, and the third step is something that we achieve pretty soon, pretty fast. But the fourth step is one that requires 10 years of work, 20 years of work to actually realize that something is not needed at all. There is a lot of examples on it, and we could speak about it after the presentation. Now, an example on how to remove something that is not needed is a framework that is gaining traction in front-end that is called Svelte. Now, a small disclaimer, people make fun that in JavaScript there is a new framework every day, right? And that we rewrite our JavaScript every 6 weeks and so on and so forth. And actually, I do not pay attention to most of the tools that are released because they repeat over and over again. They're reinventing the wheel and they're not important for me. This one caught my attention for 2 reasons. It promises that it will be a big change comparing to what we have now thanks to the virtual DOM and true reactivity. Now, a virtual DOM. Imagine that virtual DOM is the foundation of React. React is very fast because we don't interact with DOM immediately, so we change the virtual structures, which is just operating on memory. Operating on memory is fast. When we calculate all atomic changes, only then we make a very small jump into the DOM, make the changes once, make only one repaint, so that we spend as little time as possible in the expensive area, thanks to virtual DOM. Now the question is, what if we didn't have virtual DOM at all? Because virtual DOM is maintained in the runtime, right? So even if React is very fast, then it means it has to create a tree of the whole application in runtime. When a button is clicked, a new tree has to be created. Then we change the value of a dropdown. A third tree has to be created. And those trees have to be traversed in runtime. So it's not very bad, but still there is some operations and calculations done in runtime. What if we had no virtual DOM at all? And the idea behind Svelte is that it's not a library, it's a compiler, and it's a huge thing. It's a very, very complicated and sophisticated tool. It's not easy. It's convenient for us, but it's definitely not easy. It tries to track all the changes that we do in our code, and using, let's say, a snapshot of our code, a git commit, git snapshot, it compiles an application. It generates lots of very, very crappy and low-level JavaScript code that will be executed in runtime. And this runtime JavaScript doesn't have any virtual DOM. So if I click a button, Svelte knows who might be potentially changed by this button clicked. So that in compile time, there is a lot of calculations being made to know what is the direct path. Now, React creates a virtual abstraction that will make it easy to apply all the changes, whatever they are, and it's very generic and polymorphic, but it requires some runtime work. Now, Svelte removes it. Svelte basically moves the the heaviness of the calculations from runtime to compile time, meaning compile time will be longer, but runtime will be even faster than React, and they have already proven it. So this is one killer feature of Svelte. The second killer feature of Svelte, so Virtual DOM is how Svelte challenges React. True reactivity is how Svelte challenges both React and RxJS. Now, I said that in RxJS there are over 100 operators, and this is only the first step in learning RxJS, which is, as I said, a pretty significant learning overhead. Now, Svelte introduced what is called, what we can see here as a reactive statement. Basically, we have a line of code that we prepend with a dollar and colon, and that's all, right? So now we say that this is a reactive statement. So let's imagine we have a component that has a price variable, a price prop, a price state, whatever we call it. That is 9.99. We have a quantity variable, and this is pure JavaScript. Const, let, var, variables, never mind. And now we introduce what is the total price, that whenever any of the pieces change, whenever quantity changes or whenever price changes, the total price would automatically update. Now, this is not pure JavaScript, obviously, so this is where Svelte compiler kicks in, and Svelte would need to know where is this total price being used, and in each place when it's used, it would have to basically introduce this crappy line, total price, assign quantity multiplied by price. The thing is, this is very convenient to us because we don't have to track the changes. Whenever we have a dependency that would potentially require to be updated on the fly, basically prepend it with a dollar sign, and that's all. So this is how we could do a reactive stream, but also we could write dollar and then let's say a console log or a function call that uses a quantity or a price. So not only creating variables that depend on other variables to hold the invariants, but we could also do side effects basing on whenever one of the arguments change, and just prepend it with a dollar. In my opinion, this is super easy to use. This is very convenient, but I also believe that it's not professional to speak that there are only benefits and there are only pros of it, so there must be some drawbacks, right? Don't listen to people who speak only about the pros and avoid the cons, because either they don't understand the topic or they're not sincere to you, they just want to sell something to you. So what might be the drawbacks? This is not, we can see that this is some kind of custom syntax. A direct consequence is, if this custom syntax has to be supported, it has to be transpiled to something else. Now, out of the box, we lose support for TypeScript, for instance. And Svelte, instead of being in version, major version 3, it still is missing support for TypeScript. And obviously, TypeScript is not going to cover all potential magical custom syntax for all of the frameworks, because this is not TypeScript's responsibility, and this is not their goal of the strategy. So one thing is, due to the custom code, we lose support for many tools, including TypeScript. Another thing is, this is the code that we write, but this is not the code that will be executed. So now, if, basing on this very simple code, there is a crappy disposable, like disposable meaning one time, disposable JavaScript generated that is being actually executed in the platform. Now, if we have a bug, how do you think, what are we going to debug? So if we want to write big scale applications, we have to get a very strong debugging tools. This is also the same situation with RxJS. RxJS, once we understand it, is very convenient to use, but is very painful to debug. And here is even more of the problem here. So basically, this is all I've got for you. I hope that was useful. Thank you very much. And if there is one thing that I would like to you to remember after this presentation is, whenever you learn a new tool, paradigm, approach, do take time to learn the philosophy behind the tool. Focus on why do certain things work in one way or not. Consider compare two scenarios. One that you do use a tool like dependency injection or React or Redux, and the one that you don't use it. What are the benefits that you get? What are the costs that you have to pay? Find what are the trade-offs, and thanks to it, basically pick the right tool for the right job. Thank you very much.